Welcome to another episode of Learning. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems that have appeared in the JEE Main exam held in the January 2025 session. In this video, we discuss the three questions, the solutions of three questions from the section Matrices and Determinants. And this is the first part out of the 5 parts of the section Matrices and Determinants. Right. This is the question that has appeared in the JEE Main exam held on 29 January 2025 in the morning shift, that is shift 1. The given question is, let S be the set consisting of M belongs to Z such that A power M square plus A power M is equal to 3I minus A power minus 6, where A is the 2 by 2 matrix whose first row is 2 minus 1 and the second row is 1 0. You note down here this M belongs to Z, not the natural numbers. Then N of S, the number of elements present in S, is equal to. It is a numerical answer type question. Let's now discuss the solution of the problem in detail. We have A is this 2 by 2 matrix. A square, multiply A with A and write down. So A square is 3 minus 2, 2 minus 1. And we compute A power 4 as A square into A square and you get this matrix. We also compute A power 6, that is A power 4 into A square, and we get the matrix 7 minus 6 and 6 minus 5. So what are you trying to say? So this shows that A power M is equal to M plus 1 minus M, first row. Second row, M minus M plus 1. M belongs to the set of natural numbers. You can verify. Suppose you put M is equal to 6, 6 plus 1, 7, minus 6, 6, minus 6 plus 1, minus 5. And you can verify for all these things. It belongs to, M belongs to N. And if you want to say this is so, you have to apply the principle of mathematical induction and do it. And you will be losing your time. Right. Now go to A power 6 and it is non-singular because the determinant is not 0. So its inverse exists. So A power minus 6 is A power 6 and its inverse. And that will be minus 5, 6 minus 6, 7. You know how to get the inverse of a 2 by 2 matrix, A, B, C, D. Right. So what are you trying to say? I'm trying to say even this result is true even for minus 6 also. M is equal to minus 6, you substitute. Minus 6 plus 1, minus 5. Minus 6, minus of minus 6 is plus 6. Minus 6, minus 6, minus of minus 6 is plus 6 plus 1, 7. So italics. So that means your formula, this A power M is M plus 1 minus M. M minus M plus 1. M belongs to, this is true for all M belongs to Z. So why are you doing all this, sir? M belongs to N is sufficient. No, it is not. Look at S. In S, this M belongs to Z and wherein A power M is appearing here. Therefore, you should know what is A power M for M belongs to Z. So that's what precisely we did. And a kind of a shortcut that I have made here, that is by looking at all of them, I said this is true for all natural numbers, and then computed its inverse, and I said this is true even for the set of integers. Right. We continue. Right. We have a power m is this, m belongs to z. Right. Now, S is the set of all m belongs to z. Note down, m belongs to z. A power m square, of course m square is natural number, plus a power m is integer, set of integers, is equal to 3i minus a power minus 6. So this is a power m square plus a power m is equal to 3i minus a power minus 6. This will imply a power m square, wherever there is m you write m square, written here, plus a power m, for m belongs to z, is this one, and 3 times identity, minus a power minus 6 is minus 5, 6, minus 6, 7. Right. Now adding this, we got this one, multiply and subtract, you get 8 minus 6, 6 minus 4. Now, two matrices are equal if their corresponding entries are equal. This will give rise to m square plus m plus 2 is equal to 8. And the remaining also will give you the same answer. This will imply m square plus m minus 6 is equal to 0. Factorization will give you m plus 3 into m minus 2 is equal to 0. So m is equal to 2 comma minus 3. Therefore, S is this, and S is this, m belongs to z, a to the power of m square plus a power m is equal to 3i minus a to the power of minus 6. It is the set consisting of 2 minus 3. So therefore n of S is 2. It is a numerical answer type, therefore 2 is your answer. The answer to this question is 2. That is the detailed discussion of the solution of this problem. We move to the next question. Right. Here what you see is question number 3 I have written. What happened to question number 2? It is already done in a separate video and already uploaded to the YouTube. You can check it there. And this question has appeared, in the JEE Main exam held on 24 January 2025 in the morning shift. The given question is, let A be a 3 by 3 matrix such that X transpose AX is equal to 0. For all non-zero 3 by 1 matrices, that means column matrices, capital X is equal to the column vector X, Y, Z. If A times the column vector 1, 1, 1 is equal to the column vector 1, 4, minus 5, and A multiplied by the column vector 1, 2, 1 is equal to the column vector 3, 0, 4, minus 8, and the determinant of adjoint of 2 times of A plus I is 2 power alpha, 3 power beta, 5 power gamma. For alpha, beta, gamma belongs to set of natural numbers, then what is alpha square plus beta square plus gamma square? That's the question. Right. Let's now discuss the solution of the problem. Let A is equal to the 3 by 3 matrix, A1, A2, A3 first column, first row, B1, B2, B3 the second row, C1, C2, C3 as the third row. Now given X transpose AX is equal to 0, for all X, the column vectors X, Y, Z not equal to 0. Right. So X transpose, X is a column vector, its transpose will be a row vector X, Y, Z multiplied by the matrix A into X, the column vector, is equal to the 0. Right. We multiply. Right. We multiply first the row vector X, Y, Z multiplied by the 3 by 3 matrix multiplied by the column vector X, Y, Z is this one. Now multiply this row vector 1 by 3 into this is 3 rows 1 column, so 1 by 1. So that will be X times First, a1x plus a2y plus a3z plus y times b1x plus b2y plus b3z plus z times c1x plus c2y plus c3z is equal to 0. Now multiply. So you will get a1x square and here a2xy, and you will also get b1xy here. So a2 plus b1xy. So plus a3 plus c1xz plus b2y square plus b3 plus c2ayz plus c3z square is equal to 0. So this is 0 means 0 times x square plus 0 times y square plus 0 times z square plus 0 times xy plus 0 times xz plus 0 times yz. Now equating the corresponding coefficients, you will get a1 is equal to b2 is equal to c3 is equal to 0, and xy term a2 plus b1 is 0, xz term c1 plus a3 is 0, yz term b3 plus c2 is equal to 0. They are all equal to 0. So this will imply a1 is equal to b2 is equal to c3 is equal to 0, b1 is equal to minus a2, c1 is equal to minus a3, c2 is equal to minus b3. Agreed. Now a will be a1 0, b2 0, c3 0. Right. And b1 is minus a2, and c1 is minus a3, and c2 minus b3. It's a skew-symmetric matrix. It is a, just we have observed that one, it is a skew-symmetric matrix, and we are not going to use the property of this skew-symmetric matrices at all. Right. We are given the matrix A multiplied by the column vector 1, 1, 1 is equal to the column vector 1, 4, minus 5. So write the matrix A multiply with the column vector 1, 1, 1, and that is equal to 1 column vector 1, 4, minus 5. Multiply. So they are equal. So this will give you a2 plus a3 is 1, minus a2 plus b3 is 4, minus a3 minus b3 is minus 5. We are also given a multiplied by the column vector 1, 2, 1 is equal to the column vector 0, 4, minus 8. Multiply and you will get this one. Now they are equal. Therefore, 2a2 plus a3 is 0, minus a2 plus b3 is 4, minus a3 minus 2b3 is minus 8. Agreed. Now here we have a2 plus a3 is 1, 2a2 plus a3 is 0. Two equations, two unknowns, a1, a2, a3. And solving, you will get these two. Solving, you will get a2 is minus 1 and a3 is 2. It is left to you. It is very simple to solve. Right. And we take minus a3 minus b3 is minus 5. And in this a3 value, you know, it is 2. Substitute 2 and solve. You will get b3 is equal to 3. Thus we got all the unknowns. So thus a is equal to 0, a2, a3, minus a2, 0, b3, minus a3, minus b3, 0, and that is equal to the 3 by 3 matrix 0, minus 1, 2. You are substituting 1, 0, 3, minus 2, minus 3, 0. So we are ready to compute the answer. Right. Now 2 times of a plus I. So 2 times a plus I means just add 1, 1, 1 on the main diagonal. You will get 1, 1, 1. The remaining is same. And 2 times multiply. You will get this one. So call this as this matrix B for convenience. Right. Determinant of B you compute. So the determinant of this B is written here. So here what I have done is R2 minus 2 minus R1. R2 is R2 minus R1. R3 is R3 plus 2 times R1. What I have done, and so that I have made these two equal 0, so that computing and the determinant is not going to change. So computing the determinant will be easy. The determinant is 2 times 4 tens are 40 plus 2 times 10, that is 20. So 2 times 60, that is equal to 120. Now let's go and work out the problem. Determinant of adjoint of 2 times of a plus I, that is determinant of adjoint of 2 times a plus b, a plus I, we have written as b for convenience. Now determinant of adjoint of b will be determinant of b square. Why? The determinant of adjoint of a is determinant of a to the power of n minus 1. Here n is 3. So 3 minus 1 is 2. So determinant of b is 120 square, 120 square. It is given 2 power alpha, 3 power beta, 5 power gamma. Now let's see. 120 square is 120 is 2 into 3 into 5. 5. See here 2 into not 2 square, 2 square into 2 square. So anyway, so 2 cube into 2. So now 120 square is 2 cube square, 3 square, 5 square. 2 cube is 8. 8 3s are 24, 24 5s are 120. Correct. 2 to the power of 6, 3 square, 5 square is equal to 2 to the power of alpha, 3 power beta, 5 power gamma. Equating the powers, the indices, we'll get alpha is equal to 6, beta is equal to 2, gamma is equal to 2. What is that we want? We want alpha square plus beta square plus gamma square. That is 6 square plus 2 square plus 2 square. That is equal to 44. And it is a numerical answer type. Therefore, the answer to this question is 44. That is the detailed discussion of the solution of this problem. The examiner is trying to ascertain, how good you are in the computation of the matrices and determinants. That's what he is saying. Right. We move to the next question. Right. This question has appeared in the JEE Main exam held on 22nd January 2025 in the morning shift. The given question is, let A be a square matrix of order 3 such that determinant of A is minus 2 and determinant of 3 times adjoint of minus 6 times adjoint of 3A is given to be 2 power m plus n multiplied by 3 power mn, where m greater than n. Then required to find the value of 4m plus 2n. It's a NEAT, numerical answer type question. Let's now discuss the solution of the problem in detail. We are given A is a square matrix of order 3 and determinant of A is equal to minus 2. Now let us take determinant of 3 times adjoint of minus 6 times adjoint of 3A. Now determinant of lambda A is equal to lambda power n into determinant of A. So determinants of 3 times of some matrix. So 3 will come out, 3 cube lambda to the power of n, n is 3 cube into determinant of the remaining thing. Right. Now we use the determinant of adjoint of A is determinant of A to the power of n minus 1. So here determinant of adjoint of this one. So that will be equal to 3 cube into determinant of minus 6 times adjoint of 3A whole to the power of n minus 1, that is 3 minus 1 is 2. Right. And we use now determinant of lambda A is equal to lambda to the power of n into determinant of A. So this will come out 3 cube into minus 6 cube into determinant of adjoint of 3A whole square. This is all happening under the square. Why not we take out this minus 6 whole cube and to the power of 2. That is 6 to the power of 6 we can take out. And now determinant of adjoint of A is determinant of A to the power of n minus 1, because determinant of adjoint of 3A, that for that you can apply, and 3 cube, before that minus 6 whole cube whole square, 6 to the power of 6 into determinant of 3A whole square, and then square, under the square it is happening, because n is 3 minus 1. And that is equal to 3 cube into 6 to the power of 6 into determinant of 3A square and square, that is to the power of 4. And determinant of 3A is given to be minus 2. So, and one more thing, determinant of 3A is 3 cube into determinant of A. You use this one. So, 3 cube into 6 to the power of 6 into 3 cube into determinant of A under whole to the power of 4. Right. And this will be 3 cube into 6 to the power of 6 into 3 cube whole to the power of 4, 3 power 12. The determinant of A is minus 2 to the power of 4. Now 3 cube into 6 to the power of 6, we have written is 3 power 6 into 2 power 6 into 3 power 12 into 2 to the power of 4. And this is 2 to the power of 10 into 3 to the power of 21. Yeah, add the indices. Right. This you have to write it as 2 to the power of m plus n into 3 power mn. So m plus n means 10 can be written as 7 plus 3 into mn, 7 into 3 is 21. So therefore, this is 2 to the power of m plus n into 3 to the power of mn. So we get m is equal to 7, n is equal to 3, and m greater than n. Yes. Those are the m and n. And required to find the value of 4m plus 2n, that is 4 into m is 7 plus 2n, 2 into 3, and 4 7s are 28 plus 2 3s are 6, 28 plus 6, that is 34. So the answer to this question is 34. This is a numerical answer type question. Therefore, the answer is 34. That is the detailed discussion of the solution of this problem. In this, the properties of the determinants involving adjoints is used. So, the moral is, that is, you learn a lesson from this, is you must be very, you must know all the properties of the determinants involving adjoints and the properties of matrices and so on and so forth. With these few words, I say, I am sure that you understood the solutions of these 3 problems. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you are not already subscribed. I am sure we are going to meet you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.